Hey curious kids, Kevin here. So today on A Place Called Space, we are going to be learning all about the sun. Got my inflatable sun over here to help us out as we dive into what is it made out of, how hot is it, where exactly is it in the universe, and how many Earths can fit inside the sun. Then we're going to draw a diagram of what are the different parts of the sun. Diving deep into the sun to learn everything about the amazing ball of light in our sky. That's right. Whenever we talk about the sun, I use a flashlight to talk about the light. So we got the light. It's the bright, big fireball in our sky, right? It's what gives us heat. It's what gives us daytime. It's what gives us warmth. And the light is something that light, sunlight on plants, that's what they use to eat. They eat the sunlight. Do you know that? Plants eat light. So the light, another name for light, is like photons. So photo, like taking a photo, pictures. Photosynthesis, it's a big word. Plants use the sunlight as photosynthesis, and that's how they eat. Eating all that sunlight, they're like, great, and then we eat the plants. So because of the sun, we can be alive here on Earth. It keeps us warm, and then it gives the plants food to give us food. Cool? Now, what is our friend over here, the sun, made out of? You've heard of elements? Periodic table of elements, maybe you've covered that in school. So we're all made up of things, right? You've heard of water. Hope you've heard of water. Water right here. Stay hydrated, my friends. Have you ever heard water called H2O? H2O. Hydrogen and oxygen. That's what the H means. The O is for oxygen. So those are little things that make up everything, these elements. So in the sun, it's mostly made out of part of the water, the H, hydrogen. So it's like a big old ball of hydrogen with helium. So helium is the gas, the stuff that makes the balloons float. I don't have a balloon. I should have gotten a balloon. I could have a balloon here. It's what causes balloons to float. Because if we blow up a balloon with our air, it just falls down. But helium is lighter than air, and that's what causes the balloons to stay up. Now, have you heard the word Helios? Helios is a god name for the sun from mythology, right? Helios, helium, maybe there's a connection there? There is. So helium's here on Earth. It's what we put in the balloons. But the first time we found helium was on the sun. We were looking at it with some telescopes. The light was coming in from the sun, and it was going through like a window. You know how like it can create a rainbow as light comes through some glass. We were looking at that, and then we found out that it had helium. And we named it helium because of Helios. Helium, Helios. Boom. First place we found helium was on the sun. So that's the sun. It's a big old ball of flaming gas. It's mostly hydrogen and helium. Okay? Boom. Got it. Now, where is it? Right? We're here. So if it's your first time to A Place Called Space, welcome. I use this a lot because I have an X right here. See my X? X marks the spot. This is where we are, or where I am, in Los Angeles, California. So we're on Earth, and Earth and the sun, they're two different places, right? So we look in our sky, we see the sun. How far away is it? Well, it's 93 million miles away. So this distance right here in between the sun and us, 93 million miles, or I like to use kilometers, 150 million kilometers. It's a long ways. So instead of saying 93 million miles all the time, we call it an AU. The letters, A, U, an astronomical unit. So 1 astronomical unit is the distance from the Earth to the sun. Now let's say we want to figure out how far away my second favorite planet, Jupiter, with our great red spot here. So Jupiter is on this side, right? It's further away than the sun is. So instead of saying how many millions of miles Jupiter is from the sun, we say how many times more than Earth is it from the sun? So if Earth, this distance is 1 AU, how many of these distances add up to Jupiter? So we say it's about 5. About 5. So we could say like around 450 million miles, but we can just say it's 5 AU. And it's easier number to say. It's smaller, then we can do some math if we want to figure it out. So we measure really large distances in our solar system with an AU, an astronomical unit. which is that distance, right? And we're going around the sun. How long does it take us to go around the sun? You know that answer? So Earth, we're spinning, right? And you know, actually, if you watch previous episodes, if not, go check it out, all about the Earth. We're tilted 23.5 degrees, and we're going around the sun, right? So as we're spinning, that's what causes daytime and nighttime. So how long does it take to go all the way around the sun? That's a year. 1 year is the amount of time it takes to go all the way around the sun once, and it's 365 days. A little bit longer, actually, and that's why we have a leap year, to account for that little bit of extra time. So that's where it is, but we're just one star. Did you know that? The sun is a star. So this is our closest star, 93 million miles. You look up, it's one of the stars in the night sky. So if you were way far away, looking at us, you would just see the sun and it would look like a normal star. Really? Yeah, it's pretty neat. Star. Right? But where is it in terms of all the other stars? Now, have you heard of the Milky Way? Hopefully. So we live in the Milky Way galaxy. So it's this spiral galaxy. But where in the Milky Way are we? So at the center is a gigantic, massive black hole. How close are we to that? Well, there's black holes that are closer, but that's the biggest one at the center. Gotta find my little friend, computer mouse, because I'm gonna show you. I got a picture to show you where we are in the solar system. So where is it? It is, boom, right here. Okay, so here's our Milky Way galaxy. This is looking at it from like the top down. So it's a spiral galaxy. So you see got all those arms spiraling. And then if you see, we got the sun over here in the bottom. In the bottom. So we're not towards the middle. We're not in the middle of that crazy massive black hole. And we're not on the edge. We're not all the way to the side. We're like kind of right in the middle. But we do have a black hole that's closer to us. Don't worry. We're at no risk of going into that black hole. It's cool. You can calm down. It's okay. So that's where we are in the whole Milky Way galaxy. Now, our Milky Way galaxy is just one of billions of galaxies that are in our universe. But that's where we are in reference to all the stars that we can see with our eyes in the night sky. Let's bring this back. Bring me back. There we go. Kevin's big again. Woo, woo. No more baby Kevin. Baby Kevin. Big Kevin. Okay, so we talked about the sun. We know what it's made out of. But we don't know how big it is. How big is the sun? So I've got my inflatable sun here and Earth, but these aren't what we call scaled. They're not like the same size relative to each other. The sun is actually so much bigger. You can only see half of it. Let me bring it up, see? And that's not even the true size compared to Earth. It's huge. It is almost 1,000,000 miles in diameter. So a mile, right? That track around your school, like around the football field, you got to run around it 4 times to do a mile. Maybe you have to do that for like gym class. So going around that 4 times, 1,000,000 times 4, so 4 million times around that track, gets you the diameter of the sun. So diameter is from this side to this side. So if you have a circle, how big is the circle, right? Now, how many Earths can fit inside the sun? So we got our Earth here. We got the sun. Now I've got sand here. So I got my sun. Can you see that? There we go. This sun. So I got my sun cup. I got my Earth cup. Earth. There we go. I got to make sure you can see it. So if each of these grains of sand was an Earth, how many do you think could fit inside the sun? Do I stop now? Do I keep going? More? More? Stop. No, not yet. Keep going. I don't even have big enough cups. So 1 million Earths. 1 million Earths can fit inside the sun if it was hollow. That's how big it is. It is so huge. It's so far away, but it still gives us all this light, this energy, and the heat. Because you never look directly at the sun. Don't do that. It's bad for your eyes. It can burn your eyes because there's so much light and heat coming off of it. So don't look at the sun. But it's so far away, it's so big. That's what gives us all this energy and the light. And heat. How hot is the sun? Well, got a thermometer here, right? Should we stick it in the sun and see what happens? It's not going in. Well, that's because this isn't the real sun. But we can measure how hot the sun is. So how hot do you think it is? And we're going to talk in degrees Fahrenheit. I like to use Kelvin. Did you know that? So we can measure things in degree Fahrenheit. You've maybe heard of Celsius. But a lot of the science stuff we measure in Kelvin. Kelvin with a K, yeah. But we're going to talk about degrees Fahrenheit. So I'm in Los Angeles. Today's probably around 70 degrees. So we know that water boils at 100 degrees, not 100, over 200 degrees Fahrenheit, and it freezes into ice at 32 degrees Fahrenheit. So that's when it snows, right? Now the sun, the surface of the sun, 10,000 degrees Fahrenheit. That's so hot. That would definitely break my thermometer. It just wouldn't work. It'd go poof, way too hot. 10,000 degrees. So if it's 10,000 degrees way far away, all of that energy coming to us, that's why it can hurt our eyes by looking at it, because it's so bright from all that heat and it makes things hot. Like if you have a magnifying glass, don't have one, but the sunlight with a magnifying glass, you can actually burn stuff. Don't do it. It's not good. We don't need fires. We don't like to burn ants. We don't like to kill things. But that's just saying you can like bake cookies on the sidewalk if it's hot enough with the sun, because it absorbs all the sun. That could be fun. We could bake cookies on the sidewalk in the summer. It's not summer yet, so we can't do it. But maybe in a future episode of A Place Called Space, we're going to make cookies on the sidewalk. Okay, sun. How do we study the sun if we can't look at it, right? Or can we just like peek through the blinds and be like, hello? So there's a couple ways we can do it. One is we got special telescopes. Can you see me? I can see you. Yeah, Christmas wrapping paper. But it serves as a cool telescope. So we can take telescopes to look at the sun, but they're special telescopes because they have to block out some of the light if we're looking at it with like our eyes. So how do we block out light? So here's my light, right? And here, this is my little thing to block the light. So we can block all of the light like this. You see, there we go. We could, here we go. Let's do it this way. We can block all of the light like that, right? We can, this is hard. This is kind of like a game. There we go. I can block all the light like that, or I can only block like some of the light, and then we can just see the outer parts of the sun. So we can block some of it with our telescope and see the other parts of the sun. Now, I said it's how we can look at it with our eyes. Did you know that there's other types of light? Have you ever gotten hurt? Like maybe you broke your arm, you got to take an x-ray? You can see through your skin, right? And you can see a bone and you see if it's broken. It's a different type of way we can see. It's a different type of light. So we can use telescopes with different types of light to look at the sun. So we can look at an X-ray or ultraviolet. Or have you heard of thermal imaging? So thermal is heat. So if we had a thermal imaging camera on me, you would see that like my head is hotter than my shirt. My arms might be hotter because the shirt's blocking some of that heat. You would see different layers of temperature. So we can use that to look at the sun. We can also use spacecraft. I got my Lego spacecraft here. Who likes Legos? Raise your hand. So, spacecraft. We can have spacecraft that are orbiting Earth or going like behind Earth as we are going around the sun and study the sun with cameras that kind of block out that light that would hurt our eyes, or we look at it with different light. Now, there's one way that we can look at the sun. We can look at it easy. Gotta get my flashlight. So, there's an episode last week we talked about eclipses. We can study the sun in eclipses. It's actually one of the best ways we can study the outermost layer of the sun. So I'm bringing this up again, right? So the eclipse is when the moon passes in front of the sun and blocks out all the light. Well, if it doesn't block out all of it, well, even if it does block out all of it, we can see the upper atmosphere of the sun without blinding our eyes. So we can study the sun from here on Earth easier by having a solar eclipse. So that's really cool. When the moon passes in front of the sun and blocks the light, it gives us a really good chance to study the sun. Now we're looking at different parts of the sun. We're learning all of these new things. So before I tell you about the different parts of the sun, we're going to draw this out. So if you want to, while I tell you this next part, find a piece of paper and a pencil or a pen. If you have colored pencils or markers or crayons and you want to make it colorful, do it. I've got 5 different colors that I'm going to use. But this spacecraft right here, we have a spacecraft. It's in space right now. We launched it a couple years ago, and it's headed towards the sun. It's called Solar Parker Probe, is the name of the spacecraft. It is the fastest spacecraft ever, the fastest thing that we humans have made, and it's traveling to the sun. It's going to get closer than anything else. It is going to, what we call, touch the surface of the sun. Now, how close is that? 4 million miles, right? Earth, sun, 93 million miles. So this is going to be like right here. That's so close. Like Mercury is somewhere outside of it here, so it's going to be closer than Mercury is to the sun. It's going to get so hot, but we're going to learn so much about it. We want to learn more things about the different parts of the sun. So, different parts of the sun. If you've got that pencil and paper, we are going to talk about that now. Get this out of here. Let's see. Get that, and all right, there we go. Oh, you see my tape. I got some tape. Okay, I'm gonna have to turn you a little bit so I can still see you while I'm drawing this. Okay. Let's turn the light so we can see better what we're drawing. Okay, cool. So we are going to draw the different parts of the sun here. So I'm going to start with red because the sun is bright and stuff like that. So red. Now, where can you see and can you not see? I just want to make a dot over here so that I know where I cannot. Do not draw over there. Cool. So the first part we're going to start off is the center of the sun. So I'm going to draw mine not as a full circle. So not as a full circle because the sun is so big and it's got different parts. We're going to do part. So how I'm going to draw it is it's going to look like this. So just like a slice of the sun, right? Like a slice of pie or pizza. Pizza. Let's have pizza for lunch. Okay, so we are going to start off. I'm going to draw my big old piece like this. Okay, so I'm going to start off in the center right here and draw my little arch. Okay, so the main thing in the middle of the sun, same thing that we have here on the Earth, the word for it, it's called the core. So we got the core, C-O-R-E. Core is at the center of the sun. If I can make this a little brighter for us. There we go. Let's get a little better. Make sure the light's a little bit better for us. Okay. Next, we got this second layer of the sun. So what we're going to do is we're going to draw a bigger one right up around here and bring that down. So it's not perfect, you know, but hey, it looks good. I'm drawing my own core to the sun. This next part is called the radiative zone. Oh, I'm going to use my black marker to draw that, to write that down. So we got R-A-D-I-A-T-I-V-E, radiative, and then zone, Z-O-N-E. So we got the radiative zone. Okay, so we're still inside the sun. We haven't gotten to the surface yet. There's still one more layer before we can get to the surface of the sun. So let's draw another one. We're going to draw it up here at the top, right? And then bring it down like this. Okay, so what's this next layer called? This is called the convection zone. So C-O-N-V-E-C-T-I-O-N, convection, and then Z-O-N-E, like that, convection zone. Okay, so now we're at the surface of the sun. So we got the surface, but there's parts of the sun's atmosphere, okay? So up until this point, let me use my purple, got my purple marker. So surface of the sun, we'll call it right here. So it's like we got the surface. Surface of the sun. All right, and this part right here, I'm gonna use my blue. Whoa, you just saw the green marker go across. He's like, use me, use me. All right, so here we're around, you know, like the 10,000 degrees. 10,000 degrees Fahrenheit, right? Okay, so we got that. Next up, we've got another layer. So now we are moving into the atmosphere of the sun. So these parts right here are really big, right? So this next part is actually, they're super tiny. I would be drawing a line right on top of that line because they're a lot smaller. But just for the diagram here, it's not to scale. I'm going to draw a littler one and bring it off here. Okay. I'm going to use my black marker again. And I'm going to name this one. So this one right here is called the photosphere. So photo, we heard that word before, photo, P-H-O-T-O-S-P-H-E-R-E, photosphere. Okay? So this one, so that distance there, I'm going to use my purple to write underneath it. This is about 0 to 250 miles off of the surface of the sun. So that's the first layer, 250 miles. So here it's still around the 10,000 degree mark, right? Okay, we got 2 more layers. All right, so we're gonna draw another one. Coming on down. These are some squiggly lines. Are your lines as squiggly as mine? Almost like I'm giving the sun hair. It's like giving it wavy hair. Okay, next one after this photosphere. What's this one called? This is called the chromosphere. So write this down, C-H-R-O-M-O-S-P-H. That S doesn't look that good. Don't judge me on my S. E-R-E, C-H-R-O-M-O-S-P-H-E-R-E, chromosphere. Okay, this one is, I'm going to need to use my purple, is 250 to about 1,300 miles. Okay, so this is a lot bigger than Earth, right? So Earth, our atmosphere, so where does space start? We had a video about that multiple times. Space starts on Earth about 62 miles high, 100 kilometers, 62 miles. So we're way above that for the surface of the sun, the atmosphere of the sun. We got one last layer to the sun. Okay, so let's draw that one last layer. Okay, last layer. What is this called? So you may have heard this word a lot right now, and there are 2 different things. This is called the corona. Yes, so we have the coronavirus going on right now, which is why you're learning at home. For me, at this point, for a live, but the corona is the outer layer of the sun's atmosphere. So C-O-R-O-N-A, corona. That is the outer surface of the sun. Now, that is, with my purple, 1300, so 1,300 miles and up. So they don't really have a end to the top part of the surface of the sun here, the outer atmosphere. But here's the crazy part, okay? This is why I wanted to walk you through this, because it's crazy. All right, we're still trying to exactly figure out why this is happening. So we have our 10,000 degrees here on the surface, and then it's still about 10,000 degrees here, the corona. As you're going away from something, it usually gets cooler, right? It's not as hot. Like if you're having a campfire and you move away from the campfire because it's too hot, right? So if the sun's the big ball of fire and it's going everywhere, like with heat, you think it would get cooler as you go out. No, it gets hotter. So the corona out here, it's hotter than 10,000 degrees. Now, how much hotter than 10,000 degrees? 20,000? Is that a lot? Look what I write here. 900,000, 900,000 degrees Fahrenheit. That is so hot compared to the surface of our sun at 10,000. As you go out further in the atmosphere, it's 900,000 degrees Fahrenheit. We do not see that at all here on Earth, right? As you go higher up, like if you go into the mountains or in a plane, it's cold outside because as you get further away from something, it gets colder from the heat. But the sun, as you get further away, from the core, radiative zone, convection zone, up through the photosphere, the chromosphere. The corona is 900,000 degrees Fahrenheit. Now, Dad, we could bake some cookies really quick. And by bake, I mean burn. If you like burnt cookies, you can go and bake them on the sun's corona. So these are all the different parts of the sun we have. Now, there's a couple other things I want to tell you about before we just get out of here, because we're coming up towards the end of our lesson. And for that, I'm going to move you back over this way. Got to make so some people call me Baby Kevin down here, so Baby Kevin's going to go away. Big Kevin's back. So the sun. We learned about the different parts just now, but there's these things. So you see this here, here. So we've got sunspots. It's the first one. So a sunspot is a part that appears darker than the rest of the sun. So let's call it this one. So this one's darker than the rest of the sun. It's not cold, it's just a little bit cooler. So it's like, we have the sun at about 10,000 degrees. These spots are about like 6,500 degrees. So around there, just over 6,000 degrees is how hot these are. So they're not as hot, but you can still bake some awesome cookies on them or burn some awesome cookies. The next thing we have are solar flares. So that's where there's a storm going on in the sun and some energy and some particles come off of the sun, right? So the sun shoots out energy and particles because there's a storm going on. Now the last thing we have is a CME, right? And I want to write that down for you quick. So we got CME. This is a coronal mass. You can still see this, yep. Ejection. So the CME, so coronal mass ejection down there. Let's take me away for a second. And so coronal mass ejection, got to move it just a little bit so you can see it there. Coronal mass ejection. So that is when we have a huge storm on the sun. It's like, it's not just one area, it's a big spot. It's a big thing that shoots out like an arc. So it's like an arc on the sun and tons of particles just get thrown towards Earth. Where's my Earth? There it is. Bunch of particles coming off of the sun get thrown towards Earth, right? And our magnetic field, which is what we have here on Earth, protects us. Our atmosphere is what protects us from the sun. Now, it creates some really cool things, though. Have you ever heard of auroras, or the northern lights, or the southern lights? It's where you can look up in the night sky and you see a bunch of crazy colors dancing around. That comes from the sun. So the sun's particles come and they interact with Earth's atmosphere and they dance around all excited, and that's what gives us the northern or southern lights. We call them the Aurora Borealis. That's what causes them. So our sun, right? It's a star. It's in our solar system. It's 93 million miles away from us here on Earth. That's 1 AU or astronomical unit. It's about 10,000 degrees, and we've got the core, the center layer of the sun. We've got the radiative zone, then the convection zone. Then we got the surface of the sun at 10,000 degrees. We got the photosphere at about 250 miles up. It's the atmosphere of the sun. The chromosphere from 250 to around 1,300. And then the corona above 1,300 miles up. And that's 900,000 degrees. So much hotter than the surface of the sun at 10,000 degrees Fahrenheit. And lastly, we got those sunspots that are a little bit cooler than the rest of the sun. And we got solar flares and coronal mass ejections, which come off sending particles towards Earth, interact in the atmosphere, and gives us those really cool things called the Aurora Borealis that we can see in the night sky sometimes. So awesome. I'm going to see, I thought I saw a couple of questions here. So let's take a look at it. Oh, Milton, thank you for tuning back in. You were excited to learn about the sun. I hope you enjoyed the lesson. Will the sun ever lose its heat and light, says Glenn, or asks Glenn. Yes, eventually it will. So our sun is about 4.5 billion years old. And the life cycle, or the age of the sun, can get to be around 9 billion to 10 billion years. So we're about halfway through. So we got about 5 billion years until the sun goes away. By goes away, I mean it's going to burn out and we're not going to be able to have the sun like we have it now. But it's a long time away, so we're okay. How close could a rocket get to the sun before melting? Well, that depends. So the spacecraft is gone. I got spacecrafts everywhere. Here we go. This spacecraft, so it's going to get to 4 million miles to the sun because we got a super awesome shield on it to keep it cool and to like move the heat around. 4 million miles is the closest with our current technology. If that's how hot the surface of the sun is, how hot is the core? The core is around, I think it's around 10,000 degrees as well. That comes from Rochelle at Milton, I believe. Has an astronaut ever been to another galaxy from Milton? Nope. We haven't even been beyond the moon. We've only had astronauts be off the surface of Earth and go to the moon. That's the moon. That's the furthest we've gone. Let's see. When will we know how many Earths equal the sun? 1 million. You could fit 1 million Earths in the sun. And then, is the core of Earth as hot as the surface of the sun? I don't know. So we're going to look this up, because there were 2 questions that I wasn't sure on. So let's see. Temperature of Earth's core. Boom. Okay, so I'm looking it up here. And NASA says that it is about 10,800 degrees Fahrenheit. So it's about the same as the surface of the sun. Now, temperature of sun's core. Here we go. Got to make sure when you're looking it up that you find from a place that knows what's talking about, like NASA. All right, so you can type in NASA afterwards, after your question, to hopefully come up with the NASA. So here we go. See if I can show you this. See if it comes up. See how it says NASA right there? The sun, NASA, and it's about 20 million degrees Fahrenheit. Okay, so I was a little bit off by saying it might be the same as the 10,000. 27 million degrees Fahrenheit at the center of the sun, the core. Whew. Thank you for asking that question. That was a good one. We all learned something new there. I'm glad I can learn with you. All right. That is going to wrap up our episode about the sun today. I hope you learned a lot about it. If you liked the episode, click that thumbs up, right? Let me know you liked what you learned about today. If you're a fan of a place called space, it's fun to say, hit that subscribe button down below. It's like right here. It says subscribe. So I know that you're a fan and you'll get alerted for new episodes when they come back. All right? So thank you for tuning in. And remember, always keep learning. Take care.